Hi everyone. Today topic is Huffman coding based on greedy method. We already discussed about the two topics based on greedy. One is fractional knapsack problem. Another one is task scheduling problem. Task scheduling or job scheduling problem. Today we will discuss about Huffman coding. So Huffman coding is a greedy algorithm used for data compression. It reduces the size of data by assigning shorter binary codes to frequently occurring characters and longer binary code to less frequent characters. This help reduce total storage space. So one message is there, and messages, some characters are frequently occur, some characters are rarely occur. So frequently occur characters using the shorter binary code, and rarely used characters using longer binary codes. So this technique will reduce the total storage space of message. So greedy method in Huffman coding, at every step it selects the two characters with the smallest frequencies. These two nodes are combined repeatedly until one tree is formed. So this tree is called Huffman tree. So Huffman coding uses a binary tree called Huffman tree. So one tree structure is used to reduce the storage size in the particular storage space in the particular message. That tree is called Huffman tree. Okay, here one rule is there. We put the value 0 in the left edge of the particular tree and put 1 for the right edge of the tree. So the binary code of each character is obtained from the path from the root node to leaf node. The path from root node to leaf node make the binary code for the particular characters. Okay, so steps behind this. So find the frequency of each character. So given message is there, first find the particular character appeared how many times in the message. Okay, find the frequency of each character. So create a separate node for each character. So the first step is make the leaf node for all the characters. So arrange all nodes in ascending order of frequency. So which character appear less times, the leaf node is placed in the first leaf node as the Huffman tree. Select the two nodes with the smallest frequencies. Combine them into a new node by adding their frequencies. Insert the new node back into the list. Repeat the process until only one node remains. So total final node becomes the root of the Huffman tree. So that final node becomes the root of the Huffman node. That last remaining one node is the root node of the Huffman tree. So we will discuss one example that will help you to easily understand this concept. Okay, so this message is there. This is the given message. So this message contains some characters. Some characters appeared more than one times, right? Now find the frequency of characters. So here 5 characters are there, A, B, C, D, E. So these are the characters present in the given message. Next find the frequency. That means count the number of times the particular character appear in the message. Okay, then A is appeared in 3 times, right? A, here also A. So 3 times, the frequency of A is 3. Then B, 1, 2, 3, 4, 5. 5 times. Then C, 1, 2, and here also 1, 2, 3, 4, 5, 6. So 6 times 3 will appear. 3 appeared here. Then D is here 2 times and here also 2 times. 4 times totally. Finally E, this is one E and this is one E. Okay. Totally E appeared 2 times in this message. So likewise you write the particular character and the corresponding frequency. Okay. Then arrange the all characters based on the frequency. Okay, which one is the lowest frequency, you place it in first. Okay, this is 2 is the lowest. So these are the act as a load in the Huffman tree. Or these are the leaf node. These all the act as a leaf node in the Huffman tree. These are the particular characters. Okay, so E appeared in 2 times, A appeared in 3 times, D 4, 5, 6. So arrange in ascending order based on the frequency value. Okay, combine the smallest frequency. So this is entire Huffman tree is there, but initially only leaf node is there. So initially this is the structure of the tree. So only this 2, 3, 4, 5, 6, the initial node is there. Then what is the first step? The combine the smallest frequencies among these 5 frequencies, 2, 3, 4, 5, 6. So what is the two smallest frequency? That's 2 and 3, right? So combine these two leaf nodes and make it into one new node. So this node is 5. So simply add the value of two frequency values. So 2 plus 3, that is 5. Okay. Then combine the smallest frequency and make it one new node. Write the total frequency inside this node. Right. 2 plus 3, that is 5. So what is the next two smallest frequencies? Here 5 is there. Here 4, 5, 6. Right. So this 4, 5 also smallest. They take this 4, 5. Anything is possible. Take this 2 node is right and take this 2. Okay, both are valid. So here I take this 5 and this 4. Okay, so this 5 and this 4 combine. This 5 and this 4. This is the second step. So make it one new node. What is the total frequency value? 5 plus 4, that is 9. Then next minimum is 5, 6, right? Here 9 is there, here 5, here 5, 6. So this is the next to minimum frequency. So combine both frequencies and make it one new node. What is the new value here? 5 plus 6, 11. The final 9, 11. We combine these two smallest frequencies. So repeat this step until reach the root node of the Huffman tree, right? Only one node is remaining. So finally, what is the value? 11 plus 9, that is 20. This is the complete binary tree. This binary tree is called Huffman tree here. So this binary tree is helpful to make the Huffman code, right? So that's why this code, this binary tree is called Huffman tree. So what is the initial step here? This is 1, 2. This is Roman letter. Represent this step. Okay, one by one, clear? How to make this binary tree? Is clear? Okay. Okay, this is the final one. So this is the first step, right? Make the leaf nodes, then combine the minimum leaf node and make it on new node. Okay, clear? Okay, then assign binary code for the Huffman tree. So we know already, we discussed that rule. Okay, all left edge node make it as 0, right edge or make it as 1. Okay, mark it as 1. Okay, all left edge node, all the left edges mark it as 0, all the right edges make it as 1. So here these are left edge, right? Left of this, left of this. So these are 0. Here right. This is right edge of this particular node. So make it as 1. Here right, make it as 1 because here is the left of the particular node 11. So mark it as 0. Here 1. Clear? Then find the Huffman binary code for the each characters. How to find the binary code for each characters? The path from root to the particular character leaf node. Okay. So these are the characters, right? This E appeared 2 times in the message, A appeared 3 times, D appeared 4 times. These are the frequencies used to make the leaf node in the particular Huffman tree, right? Then travel root from path from root to leaf node to make the binary codes of the particular characters. So now we first make the binary code for the characters character G. So travel from root to leaf node. So 0, 0, 0, we reach E here. Right? What is the binary code for E? That is 0, 0, 0. Then A, right? So 0, 0, 0, 0, then E. Then reach character A, right? Then the binary code is 0, 0, 1. Here D 0, 1, right? Here 1, 0, that is B. Then 1, 1, that is 6. What is the beauty here? The particular character, the character E and A appeared less times in the particular message. The frequency is very low, right? So those characters, here those characters have 3 binary codes, but in frequently occurred characters D, P, C are using the 2 binary, represented using 2 binary codes. Okay, this will helpful to reduce the total message length. Clear? So the final answer. So this is the character, this is the frequency, this is the Huffman code. Here A and 2 frequency is 3 using 3 binary code. Okay, 3. The binary code length is 3. So longer frequency sorry, here the shorter frequency, right? Shorter frequency using lengthy binary code, but these are the longer frequency, right? So longer frequency use lowest binary code. Clear? So these are the, so these three characters B, C, D appeared many times in the particular message. We using binary code length 2. Here 3 and 2 appeared less times, so using binary code length is 3. So this is the encoded message. We just substitute all the binary code value of the corresponding characters. Then what is the total bit here? Here B, how many times B appeared? B appeared 3 times, right? Sorry. Just multiply 3. So A appeared in 3 times. So what is the Huffman code length? That is 3, right? So 3 into 3 plus B appeared 5 times. 5 into 2, 10. Then 6 into 2. Then 4 into 2. 2 into 3. So likewise, you multiply all those things and finally adding all the values, finally get the total bits needed to make this encoded message. Okay, that is finally we need 45 bits to convert this message into the encoded format. Clear? So this is 3, 2, 2, 2. These are the length of the binary codes. Okay, 3 into 3, 5 into 2, 6 into 2, 4 into 2, 2 into 3. This is length of binary code. Okay, so this is the overall procedure in the Huffman coding using greedy method. Clear? So first step is leaf node. So this is the first step. Initially the tree contain only leaf nodes and combine the minimum frequency and make it a new node. Right? Here the minimum frequency 5 and 4, make it this node. Then make third this. Finally make this node. Likewise, you make the complete binary tree. The tree is called Huffman tree. Okay, then put the edge value. So left the edge present in left side means put 0, right side means put 1, and make the code using the path travel from root node to the particular leaf node. Okay, the character leaf node. Then find the binary code. So finally find the total bits equal to the frequency, the particular character's frequency into the binary code length. Clear? So if you have any doubt, write it in the comment section. Thank you.